All right, we're back. We're on page 36 of math analysis, and we're going to do some point in the plane problems here. So let's see how it goes. So we need to figure out what R is. So here, I know that 5, 12, 13 is a Pythagorean triple, and that's what you want to do. You don't want to waste a lot of time finding things that you are supposed to know. So we already know that. So we could actually just write everything down at this point. So let's say sine of theta, cosine of theta, tan of theta, a lot of equal signs. And then we got cosecant, secant. So if you organize them the same way every time, it's like less of a cognitive load. And you know, you got enough going on. You don't need to overburden yourself. So I'm actually going to move these a little bit and duplicate them so that I don't have to rewrite it every time. So let me see. Just saving myself some time, probably not you. And then one more. Oh, crud. Undo, undo. Uh, Duplicate. I accidentally dropped it. Okay, so let's do these. So I know there's two ways I can do it, right? So one way is I can say that I know that sine is y over r, so it'll be negative 12 over 13. Cosine is x over r, so it'll be 5 over 13. Tangent is y over x, negative 12 over 5. Super fast. Nothing wrong with that. So the only warning I would give you on this is that I actually think that takes less thinking than doing the problem through a triangle. So I think that it's actually a little more useful, as in long-term remembering, to do this. So I'm going to draw myself, let's say here. So I'm going to draw myself a triangle here, and then. Okay, I know that the angle I'm interested in, the actual theta, is this angle. But what I'm going to do is I'm going to think about alpha. And for alpha, because this is the point 5, negative 12, this side here is positive 5. This side here, it's a directed distance. So what is going on? That's going to be negative 12. And then I know this is 13. So in this triangle, opposite over hypotenuse is negative 12 over 13. Adjacent over hypotenuse is 5 over 13. Tangent, negative 12 over 5. I prefer to use these triangles, but you might not. And it's totally up to you. You do either way, it doesn't make a difference. We also I want the exact angle also. So I know I'm in quadrant 4. So theta is an element of quadrant 4. Therefore, theta is going to be 2 pi minus the reference angle. And the reference angle, so the reference angle, remember the safest way is the inverse tangent of the absolute value of y over x, so 12 over 5. So we're taking the absolute value to avoid the issue of doing the inverse tangent of a negative, which is actually a. So the inverse tangent of a negative is a negative, which means that if we wrote inverse tangent of negative 12/5, we would actually be doing 2 pi minus a negative, 2 pi plus something. We'd actually be ending up with a quadrant 1 angle, which we do not want. So we put in the absolute value, we never mess that up. That's my recommendation for you. Don't mess around with that, just get it done. 2021-29, because I memorized it. It's also my favorite, so you should probably memorize it too. It's going to show up everywhere. All right, so negative 21 over 29, negative 20 over 29, 21 over 20, and then reciprocals, flip, 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 and there. But I think that the better way to do it is to draw a triangle. And so I'm going to do that over here. So this will be a third quadrant thing. So it's going to be like kind of here-ish maybe. Why would you turn that into whatever you turn that into? Okay, that seemed to work better. Like this. Okay, so for me, I'm going to have alpha. So I know theta. Theta is theta's the big angle, right? Theta's all the way here. But I don't want that. Well, I want that. That's what I'm dealing with. But I want to deal with this angle. And for this angle, since this is negative 20, negative 21, I know that this directed distance is going to be negative 21 because it's the y coordinate. I know that this directed distance is going to be negative 20, and this is 29. And then from there, opposite over hypotenuse, negative 21 over 29. Adjacent over hypotenuse, negative 20 over 29. Tangent, opposite over adjacent, 21 over 20. So you're getting all those things. You're avoiding having to memorize too much, which is really like what I try to avoid, because I mean, it seems weird that I'm saying that because I'm telling you to memorize everything. There's so much that you need to memorize that if you don't need to memorize it, like find another way. And here we can just draw a simple triangle, get everything we need. That's what I recommend, but it's up to you. All right, so reference angle is going to be the inverse tangent of the absolute value, which in this case is the same thing, of y over x. And then we're in quadrant 3. Therefore, theta is going, so I guess theta is an element of quadrant 3. Therefore, theta equals pi plus the reference angle. And there you go. You can't actually do better than that. Like, it's not going to look any better no matter what you do. That's the exact value. And at the end, maybe we'll check these. Maybe. See how that goes. All right. 6 and 10 have something in common. They have a 2 in common. So instead of using 6 and 10, I'm going to use the ordered pair 3 and 5, because 3 and 5 and 6 and 10 are actually just scalar multiples of each other, right? Multiply 3, 5 by 2, you get 6, 10. They're on the exact same line. If they're on the same line, then all the trig functions will be the same. So you should always look and see if you can reduce your given point. If you can, do it. It'll save you so much time. Because once you have 3, 5, r is just a little smaller. It's smaller by a factor of 2. And so all your ratios are going to reduce down the same, except now, because you took out that common factor, you're going to get them in simplest reduced form. And that's what we want. So this will be the square root of, I guess I'll write 9 plus 25, square root of 34. All right. So sine is y over r. Cosine is x over r. Tangent is y over x, so 5/3. And then reciprocals. Okay. But again, I think the better thing to do is to draw your triangle and work from there. I'm not going to do that though. But here, if you directly found r, it would be the square root of 36 plus 100. So the square root of 136, which is actually, so 136 is 4 times 34. So this would actually be 2 root 34. And you can see that you just introduce a factor of 2 everywhere. You're going to get 10 over 2 root 34, which will simplify to 5 over root 34. You're going to get 6 over 2 root 34, which simplifies to 3 over root 34. Skip that step. Just use the reduced form to begin with. Now, what quadrant are we in? So this is another place where if you draw the triangle, it's going to help you out. Something like that. Here. So this, I'm going to use 3, 5. And then this I know is radical 34. So we're definitely in quadrant 1. So let's say 3, 5. This triangle is the real triangle. Alpha and theta would be the same in this. So let's see. So our reference angle is our angle. So it's going to be the inverse tangent of 5/3. So theta is an element of quadrant 1. Therefore, theta actually just is the inverse tangent of 5/3. All right, not bad. Let's do, crashed it. Really crashed it. What was this? Dang it. All right, hold up. Hold up, everybody. Okay. I think I got it back. Did I just somehow erase all of this? That would be disconcerting. Oh no, I'm in the wrong app. Wow, this is going really well. Here we go. Here we go. Okay. Is this? All right, what I'll do, I'm gonna finish this problem. Then I'm gonna stop the video. I'll come back in the next video. I'll check all of these answers and do the next problem. That's my plan. Tentative plan. So we need an R. So R is, also, I really need to learn, like when this crashes, I really need to learn a better way to like fix it. What I need to do is like, what I currently do is I open another app, then I drag that app so I can see all of them, and then I like close it, and I go back in. It's not really great, but you know, you do your best. All right, radical 89. So let's see. I'm just gonna do this one the quicker way, which is not necessarily the better way. You know, it's trade-off. And then we'll like fix, oh, whoa. Why am I sometimes writing 84s here? Get out of there. Okay, 89, 89. So that was good. That was a good pickup there. All right, we're in quadrant 2. Okay, so the reference angle, doesn't matter what quadrant I'm in, my reference angle is always going to be the inverse tangent of the absolute value of y over x. But theta is an element of quadrant 2. Therefore, theta equals pi minus tan inverse of 8/5. All right, so stop here, come back in the next video, check all of these, fix anything that's wrong, and then do the next problem and be done with this page. So I will see you there.